Hello, guys. So, welcome to another new episode of Computer Networking, and thank you for joining me today. So, we are going to look into another layer of the OSI, which we spoke about. So, now this is going to be focusing into the network layer. So, routing is a very essential part of the whole connectivity process. So yeah, so let's I hope this episode can give you a lot of information, and also you can learn a lot from this. So maybe you have always wondered, how can data just travel so fast and seamlessly across the internet? Whether it's an email or whether it's a simple web search, or a message to your friend saying, happy birthday on her special day. How does all of this happen just in a few seconds? Now, it's all thanks to the development of routing. So, today, I hope you can get some deep insights into this concept, and also see how it has evolved over the years, the decades, its principles, and how it powers the modern network. So, by the end of the video, if you are still remaining with me, make sure to like, comment, and subscribe to my channel as well. So let's first take a look into the definition of routing. So routing can actually be defined as the process of selecting paths in a network through which data packets travel from the source to the destination. So to explain this in my own words, at its core, routing is the process of determining the best path for the data. So, the best example that I can take for you, give you at this moment is, um, think about the GPS, the GPS that is in your car. So, when you enter the destination, into the GPS makes sure to take you through the most efficient road to your destination. So it is the same for data. So routers make sure that these data arrive at their destination using the most shortest and the efficient um, way, and does not waste any time being subjected to unnecessary data traffic, right? So let's take a look at the key concepts. So when you talk about routing, most people think, oh, we are just talking about the routers that you see at home, which that provide the internet connection. But no, it's not just the routers. Of course, it is an essential device that you know gives us all these special connectivity abilities. But also, when you talk about routing, there's the protocols, and there's also the routing tables. So in this video, I think I will dive deep into the protocols more, so you can understand how data is how information is interchanged using what kind of methods. Um, so why is routing important? So as a matter of fact, everyone talks about the internet, how it has enabled us to see people in, a split second, send messages, emails, and even have online meetings to take important boardroom decisions. But what people don't know is that all of these is enabled not because uh, of the company Google, or maybe Firefox, not because of the web browsers, but also because of the routers and the routing protocols that make sure that data is transmitted so quickly in a split second, right? So the importance is very, very huge. But if I were to like sum it up in few points, it would be the efficient communication, and also the fault tolerance, where when data is lost in the process, that does not mean that your message is lost. Your message is still transmitted because the routers make sure they find alternative paths to send your message. So how crazy is that, right? And also the scalability. So maybe your organization grows, expands its process. Imagine you're in an organization and it grows, expands its activities overseas. So even then you can still be connected because of the scalability of the routers, right? So let's take a look at the history of routing. So actually it was invented in the 1960s, and it actually emerged with the development of packet switching, which is also a revolutionary breakthrough for the networking industry and the whole IT industry. But um, it was actually first routing started with the advanced research projects agency network. So they invented most of the earliest routing protocols. So initially it was just static routing, but by the 1970s we saw the development of dynamic protocols, uh, like the RIP emerged. So and the 1980s there was an introduction into new protocols like the OSPF, which actually revolutionized the whole routing mechanism. So I will be talking about these in detail in the next few slides. So that was the history of routing. So it is actually very, very it has, the history of routing, it just keeps on expanding, because I think today we can see still there is improvements that can be done into this network layer by breaking barriers through new methods. So actually routing is all wrapped up in this concept of the optimality principle. So I can say that optimality principle is actually the cornerstone of routing. So it says that if there's imagine there is a connection established between router I and router K, and router J is also in the middle of the transmission process. So if the path from router I to K is optimal, that also means that the path from J to K should also be optimal. So initially this sounds like a joke, but when we are diving deep into the concepts of networking, I think this helps to make sure that a lot of concepts are um, proved. um, yeah. So the other thing is the sync tree. So the sync tree is actually another very, very important concept. So in a sync tree, it is a special structure where all the nodes are connected to a single destination, which is the sink. So in a sink tree, every node is connected to the sink using the shortest path, and this ensures that all data takes the most efficient route to reach its final destination. So it is considered a powerful concept for organizing and also optimizing network traffic, right? And I want to show you a picture of how a network would look without a sync tree, and also a picture of how a network would look with the sync tree, right? So you can see how much of a construction cost is lowered. So actually this is not just implemented, this principle, the optimality principle, is also we can see it being used in so much of construction and architecture kind of, uh, when you're building a road, railway, there's also the optimality principle being used, where you do not connect two cities if the connection is not needed, right? If a person can travel to that city through another city, then it would be pointless to construct a whole new railway just to join that city with the rest of the other cities. So that is, I think, a very simple way to explain this. And also, the next concept we are looking at is the shortest path algorithm. So the shortest path algorithm heavily relies on things like the Dijkstra's and the Bellman-Ford. So actually, the Dijkstra's algorithm is very popular for finding the shortest path using positive weights, which makes it um, ideal for real world applications. But the Bellman Ford algorithm, on the other hand, is very versatile and handles negative weights, which is very surprising because the extras is positive and then it goes to negative. But it can also be seen as a less efficient method for large networks. So it depends on the scalability of the network, how large you want your network to grow. So depending on that, I think right now the Dijkstra's algorithm is what is gaining a lot of popularity. So this is a picture to understand better how the shortest path algorithm works. So it is indicated in pink from A to point B to point E, and how data flows and how connections are being made. So similarly, this is the Dijkstra's algorithm, the coding, and also how it is being done. So for example, I would take, from if you're traveling from point V1 to, let's say, point V5, are we going to travel through V2 and reach V5, or are we going to travel through V3 and reach 5? So it um, depends according to the weights which are given beside the line. So you add up all the weights and you decide to take what is the lowest weight. So if a construction show if a connection shows you a lower weight than the other connection, then you would choose the one with the lower weight rather than going for the one with the higher, because this will drastically reduce your construction cost or the cost of the whole project as a whole, and it is much more efficient that way. So then comes the concept of flooding. So this concept is actually very, it does not take into consideration the optimality principle. So it does not go hand to hand with the optimality concept, if I was to tell you. So it's not just the flooding where your houses just gets washed out, but this flooding is actually when uh, a packet is sent to every node in the network, thinking um, that every node is free. So it actually guarantees delivery, but at the same time it is very inefficient because it creates a lot of redundant traffic, right? So because of this thing, it is rarely used in real networks, but it can be helpful in specific situations like network discovery, right? And the other thing is the distant vector routing. So RIP, routing information protocol, it falls under this distance vector routing category. So it is where each router shares its routing table with the neighbor routers periodically. So the protocol use this method to calculate the shortest path to the destinations based on the distance matrix, right? So initially it is very simple to implement, but it can run into problems like the count to infinity issue. So this issue is a topic for another video. So because we don't have time, we will be looking at our next slide. So if you want to know about this, please let me know. And the other one is the link state routing. So the link state routing is actually open shortest path first, so, kind of thing. So this is what I spoke about before as well in the introduction, if you can remember. So the link state protocol is where the routers share information about um, the whole network, the complete picture of the network with the other routers, and using the topology map, routers calculate the shortest path using algorithms like the Dijkstra's, which we saw before. So this is actually a much more advanced version of the normal static routing, but I think this is also a very important breakthrough. So then comes the hierarchical routing, which is the last routing system, the protocol we are going to discuss for today, because the algorithm we are going to discuss for today, because time does not permit us to carry any further. So this routing is actually divides the entire big whole network into small regions and parts, and separates it, and make sure that the network reduces the excess information and only provides the information that is needed for the entire subcategory. So it improves scalability, so you don't have to worry much about the growing network. So this is actually how the BGP managed the internet very effectively. So in the internet you find so many layers, so that's a whole new topic which we might discuss later. But yes, thank you very much for your attention. I want to tell you that routing is actually a very broad topic where new things are being added every day. So with the introduction of things like AI, 5G, and IoT, there's routing is becoming smarter and adaptive and very flexible. So thank you for joining me. So if you have any questions, please forward it to me, and I can help you in any way possible. So thank you so much for staying through to the end of this video, and if there's any unclear parts, make sure to email me so I can maybe give you a better detailed explanation. Thank you so much. See you guys on the next video. Bye.